Hello, welcome again to the Academy. This is part of a series of video lessons on Cal 3 topics. Today we're talking about multivariate chain rule, the multivariable chain rule. So if you remember from single variable calculus, the chain rule, where you have a function of a function, for example f of g of x, and you want to take the derivative with respect to x, take the derivative of f with respect to g, then multiply by the derivative of g. Or if we have g, we say u equals g of x, then you would have another form of the chain rule, which is this. This is the derivative of f with respect to x is derivative of f with respect to u times derivative of u with respect to x. You can see how sort of magically the du's will cancel out, even though that's not exactly what's happening. And there's a similar thing for functions of many variables. So for the multivariable version, we consider a function of x and y. And x and y, like g of x, are also functions themselves of some variable t. So x is x of t and y is actually y of t. And so let's say you want to take, for example, the derivative of f with respect to t. It's also called the total derivative. The chain rule states that it is the partial derivative of f with respect to x times the derivative of x with respect to t plus derivative of f, partial derivative with respect to y times the derivative of y with respect to t. Y over t. And once again, you can sort of intuitively see that these sort of cancel out somehow, give you derivative of f with respect to t, but it's twice, so it doesn't really work this way, but there's still a kind of a similarity between the two. But this is the chain rule, at least for two variables. Of course, another way you could do it is just by substituting x and y, if you know that they're functions of t, and then just find the regular derivative. So we'll show that this works by doing an example. So let's say f of x comma y is maybe x1 squared minus x squared minus 3x squared, for example. And then let's say x is x of t is 2t and y of t is t minus 1. Let's do 2 squared minus 1 for the sake of this example. So now we have two ways of doing it. One, we can take the derivative with the chain rule, or you can do it by direct substitution. So first, let's just do it the substitution way. So that means f of t now becomes, well, if we substitute this, that becomes 2t times t squared minus 1 squared minus 3 2t squared, which is 2t times t to the fourth minus 2t squared plus 1 minus 3 times 4t squared is 2t to the fifth minus 4t cubed plus 2t minus 12t squared. So f prime of t, which is derivative with respect to t, is that would be 10t to the fourth minus 12t squared. Let's do this one first, minus 24t plus 2. So that's the derivative if we directly substitute it. And now we can calculate it using the chain rule that we have over here. So we directly proceed to this. So now we have this equation right here that we rewrite it. So we have the partial with respect to x times derivative of x with respect to t. This partial derivative with respect to y times the derivative with respect to t of y. So what's the partial derivative with respect to x? Well, if we just look at this function right here, this is a constant, so that's y squared minus, that would be 6x, times what's the derivative with respect to t of x, that's just 2, plus partial of f with respect to y is, so that's equal to 2xy, and the rest of the constant, so it's 0, times derivative of this would be 2t, derivative of y with respect to t. Now, of course, we can substitute back, so y squared, we know, is t squared minus 1 squared, minus 6 times 2t, the whole thing times 2, plus 2 times 2t, t squared minus 1, times 2t again. So if we simplify this, we should get t to the fourth minus 2t squared plus 1 minus 12t, that's 12 times 2, plus 4t times 2t, that will become 8t squared, t squared minus 1, and we just put this in here, it's 2t to the fourth minus 2t squared plus 2 minus 24t, plus this becomes 8t to the fourth minus 8t squared. And that becomes what? It will become this, right? It's 4t squared over here. Okay, so 2t to the fourth, and then 8t to the fourth, that makes 10t to the fourth. How many t cubes? We don't have any. Negative 4t squared and negative 8t squared gives negative 12t squared. 24t minus 24t, t plus 2, and I think that's what we got over here. Yes. So we can see that the chain rule worked. One interesting thing that we can do with this multivariable chain rule, we can actually create a proof for the product rule. If you remember from single variable calculus, product rule states that if your function is, let's say, g of x times h of x, then the derivative would be the derivative of the first times the second plus the first times the derivative of the second. And we can prove this using the multivariable chain rule. So here's a quick proof. So we start with f of x. Actually, this is f of g and h. So g and h now are our functions, or g of x. So g is a function of x, and h is also a function of x. So now we're trying to find the derivative of f with respect to x. Here, this is the formula tells us that it will be the partial derivative of f with respect to the first variable g times derivative of g with respect to x plus would be the partial derivative of f with respect to the second variable times the derivative of the second variable with respect to x, the final variable. So what do we have here? F of g of a, f of g comma h equals, in this case it's just g of x times h of x, so that's just g times h. So now we can calculate this. So the partial derivative of f with respect to g, well, h is a constant, so the derivative with respect to g is just h, and the derivative of g with respect to x is g prime, plus partial derivative of f with respect to h, well, since g is a constant, it's just going to be a constant of h, so this is just going to be the constant, times the derivative of h with respect to x, h prime, or you rearrange these as g prime of x times h of x plus g of x times h prime of x, which is what we're trying to find. And so there is the interesting proof using the multivariable chain rule. I just want to talk about another version of the chain rule. What if you had, so you had f of x comma y, but x and y were also multivariable functions, functions of u, v. Well, now we can find the derivative of f, partial derivative of f with respect to u, and similarly would be this, plus partial derivative of f with respect to y, and the partial of x with respect to y here, with respect to u, and the partial of f with respect to v similarly will be partial with respect to x times the partial of x with respect to v, and then add that same situation with y. These are the two formulas for this situation. And that's pretty much all the information about the multivariable chain rule. Thanks for watching, and I'll see you in the next video.